This event is one of the most prestigious ones on the British Computer Society calendar. We hold a number of distinguished lectures each year, Turing Lecture and Roger Needham Lecture and so on. And the Lovelace Award is no lesser candidate for its high value than the others. I won't give you the lecture about Ada Lovelace or the history thereof. That would be insulting your knowledge. But suffice to say that this annual lecture pays due tribute to a lot of our computing heritage. It's traditional at each one of the lectures to announce the following year's winner, and I will do so at the end of this particular evening. And last year, at last year's event, this year's winner, Dr. Tony Story, was named as the winner of the Lovelace Medal for 2008. And ideally, we would have had Tony Story here to deliver a lecture in person. But Tony is not well at the moment, and I would therefore like to invite a very close friend and colleague of his, who's known to many of us, Ian Nussey, who would like to say a little bit about Tony and give you some background to his award.
Well, thank you very much, Alan, for that introduction. When Tony Story learned that he'd won the 2009 Lovelace Medal more than a year ago, his response was absolutely in character. Initial disbelief, followed by a genuine attempt to refuse it on the grounds that so many colleagues had been involved in what he'd been doing, and adamant in declining to give a public lecture. Though, I have to say, if he'd agreed, you'd have had a real treat. But sadly, though, that decision proved all too prescient. And that's because he was forced to cry off tonight at the last moment due to starting some unexpected and rather challenging medical treatment that began this afternoon. And I know I'm speaking for everyone here in passing wishes to him regarding a swift and good recovery. And for my part, I'm very proud to be standing in for a wonderful colleague, indisputably one of the world's finest computing professionals. So before I get to speak for Tony, I thought I might use some of my allotted 5 minutes to tell you a little bit more about him. He's got many towering achievements to his credit, far more than appeared in the bio that you've got in front of you. He's a self-taught software engineer, and he began by creating a real-time operating system for Ferranti, and then he went on to prototype the world's first relational database demonstrator, which was the precursor to DB2. He was the chief architect and driving force between two of the world's most successful middleware application programs. First, by re-engineering Kix for scalability, function, and performance, such that it now handles billions of financial transactions each day for almost every one of the top 500 companies in the world. And going on to conceive and design MQ, now MQ series. That's the messaging product that transfers trillions of dollars a day with complete integrity, and the first software product to win Britain's most prestigious engineering award, the MacRobert Medal. And although IBM doesn't disclose revenue for individual products, it's an open secret that CICS and MQ revenue is now well into 11 figures, though only of dollars. He brought sanity to the year 2K debate. He's made a massive public service contribution in areas like e-science, the only industrialist on the national board in grid and open standards. But there's a lot more to Tony than just superb software engineering and a nose for the products, the sort of products that customers need. He's someone who invariably sees through the glitz and fog to the heart of a problem. He's lethal at calling out poorly conceived plans and strategies. and unhesitatingly vocal when he thinks management is getting in his way, or when unpalatable messages which have been glossed over need to be exposed. It's entirely in character with this man that he breeds tortoises, currently owning about 10 of them, and many of my colleagues owning rather more, because he shares certain characteristics in common with his top male tortoise. Rampant obsession with finding pastures new, constantly seeking escape from his high-walled garden, slow, steady, and very determined. Constantly complaining about being constrained, doggedly tenacious about getting his own way, and definitely smart enough to succeed in that. But he does, however, have a few weaknesses. Rock music to excess. He's a self-taught guitarist. Addiction to quite unbelievably expensive hi-fi. Unable to resist pursuing lost causes, though that, of course, is something all great people need to do if they're to succeed in pushing the envelope. But perhaps his worst weakness is that he's a fanatical supporter of Southampton Football Club. It's consequently unwise, unless you've got time on your hands, to ask him what he thinks of Harry Redknapp and the current squad. Returning to the positive, the thing that his colleagues most revere him for is the way that he looks after people, because Tony truly cares. He's brilliant on promotion boards, vocal in support of quality people, tenacious in establishing candidates really do have what it takes, and great at making sure that quiet, unassuming people with real potential do get a fair hearing. And he's a wonderful mentor in the classic sense of being a wise counsellor and faithful friend, hugely generous with his help and availability. Significantly, all those he's mentored seem to have adopted his values in that respect, and very many of them are already on stellar careers. Well, there's a lot more that I could say about Tony, but it's time to turn to my original brief, which is to speak for him. So what do I think he would have said if he were here? Well, that he's totally overwhelmed by this recognition, that set against previous Lovelace winners, he doesn't deserve it. That if there was one piece of advice that he would offer to aspirant computer professionals, it would be to keep testing their boundaries, have faith in their own judgment, and let no one stop them doing what they think is right. And finally, he would have wanted to thank our society for affording him this very special honour. And I thank you too for this attention. Thank you very much.
Usually at these events, the award is made. On this occasion, I would like to tell you that the BCS will undertake to ensure that the award winner receives his award in a duly appropriate manner after this event. Now, we're very, very fortunate and most grateful that a lifelong colleague in IBM and friend of Tony's, Maurice Perks, is actually going to talk to you this evening. Maurice probably would say that he's going to give his own talk because he probably couldn't do justice to Tony's own brain, but I can assure you that Maurice has a fantastic brain of his own, and you will hear something this evening that will be well worth listening to. Maurice is an IBM Fellow. There are only 67 IBM Fellows in the world, and it's a senior executive position that is reserved for the very top echelon. So we're very fortunate to have Maurice here this evening. He is also one of those people who can see both sides of arguments. He is equally at home talking to people in depth on technical issues, or briefing those with only a passing acquaintance, sometimes at board level when they should know more, about our profession and about technology and information. He's also a man after my own heart, in that he fully appreciates the benefits of new technology, but is not beguiled into thinking that they're the answer, the immediate answer to any prayer on an overnight basis, and that therefore a healthy dose of scepticism characterises his approach to using technology. So I'm very, very pleased on your behalf to thank Maurice for giving up his time to be here with us, and we look forward very much to hearing him talk.
Okay. Could I have my slides, or here they are. That's what I'm going to talk about. I thought we'd have a racy title with the word sins in it to attract a good audience. Okay. This is my presentation, Maurice Perks. If you want to argue with me over the internet afterwards, well, do that. You're probably still wondering, well, what really is this guy here? I describe myself as an IT engineer. Right? That's why I carried my tool bag up with me, right, for partial proof, and the final proof is the oily rag. Right? I spend a lot of time deep down in nasty things, trying to work out why they're nasty. Okay. As I go through, if anyone's got the desire to rush down and give me money, please don't. As you can see from my name, I'm already an MP. Right? We have something topical. All right. What I'm going to do as I go through this is I'm going to bring in text, fly in text. There's not a lot of animation until we get to a set of pictures in the middle that's going to bore you all to death. And that's the objective of the pictures. So what I'm going to do is go forward. And first of all, though, have a disclaimer. Always have to have a disclaimer, which is that any of you who are from the press in here who want to write about this and say, oh, these are all the mistakes that IBM makes in projects. They're not. Sometimes we do. They're an amalgamation of mistakes I've seen made over about 40 years by all sorts of service providers, but always real customers, real enterprises sitting out there. Right, so that's the disclaimer. And then the acclaimer. I don't think there is a word called acclaimer, but it doesn't matter. There is now, right? I dedicate this to Tony Story. Tony and myself were made fellows at the same IBM ceremony. So we've got a very close bond between us, right? And that's my dedication to him. Okay. What I'm going to talk about, and I'd like you to think about the landscape of this, are IT projects that are actually executed in what I'll call medium or large enterprises. Right? We can all debate what a medium enterprise or large enterprise is. In the private sector or the public sector, it doesn't matter. Okay? And basically, I've seen a lot of these as we've gone through. And if I characterize them, we're quite often successful, but our industry as an industry has a lot of failures, right? And failure is measured by we do not deliver the function on time to budget. Okay, that's something that's been pretty constant throughout my career. So the objective is to, right, get more success in these, and if we do this, then both the economies in the private sector and the quality of life in the public sector will be better for us. And even today I heard something from the Bank of England which said, oh, the economy is going to contract by 4.5%. So if we can be just a bit better, right, the economy might only contract by 4%, or it might grow by 4% rather than 3.5%. So I think IT has a large gearing on the economies, both in the private and the public sector that we've got. Okay? So what we do is we introduce risks into projects. And if we can identify these risks, And I'm not going to have huge lists of them here today. That's not the meaning of this lecture in the time we've got. But if we can identify them quickly, then we can avoid actually making some of the mistakes. And the reasoning behind this is that I think after really thinking about this for a long, long time, our industry is not based upon what I'll call a set of physical laws, like other engineering type industries are, right? But there are some patterns that we can see which we might imagine are laws. I'll come back to these at the end, okay? And if everyone goes out of this room saying, I didn't hear anything new in this lecture, I will have achieved my objective, right? And the real question is, why do people keep talking about these mistakes? Why do we keep making them? Right? So it's these patterns that we're going to come back to. Okay? Right. Large IT projects. What's the definition of a large IT project? It varies between people who think it. My definition is one that lasts over 1 year. And the reasoning behind that is, in that time, things change. Okay? And you get the question, why do we have these large projects? Why? What's the intrinsic factor? The answer is that if you go into large enterprises, let's say a bank, whatever you're going to do there is going to be large, right? It's going to have lots of things in it. If you try and do something in the government where there are lots and lots of citizens involved, it's going to be large. You can't have it small. It's a fact of life. So we have these large IT projects. It'd be nice if we didn't sometimes. It's great when we make them successful. Right. And so what you actually see in our industry is the technologies that we use, the basic raw materials, change like no other industry that I know to. Right? If you start a project off at 1 year, within about a year of the going of the project, some of the technologies will have changed. Some of the business requirements will have changed, right? So we're in an industry that really does actually have at its heart all this change going on all the time. And it's to manage this change that's important. Okay? Also, we have a huge diversity of skills in there. We start off with business people who understand the business, and they start talking and talking, and we come down to all sorts of business analysts, architects, programmers, designers, testers, and etc. And they're all sitting in these projects, and underneath them, back in the industry, are people who are designing chips and servers and storage devices as well. So we've got this huge width of skills that we have, and these churn around as well. And we have a problem sitting in there that it is very difficult sometimes for one of these towers of skills to communicate with the next tower. I occasionally sit in on meetings of chip designers, etc. I have no idea what they're talking about. And then I start talking about enterprise system design, and they have no idea what I'm talking about. Right? When you work in a company like IBM, you can do this. And so we've got this communications problem as well. Right? But these large IT projects have another sort of property to them, and that is they cost a lot of money. So when you fund them, they often get funded in the private sector by a board decision, and then they are watched by the boards of companies. Or in the public sector, they get funded by Parliament, and we know what happens there, right? As what happens. So because they're large and they've got so much money involved, they have this visibility. They're under the microscope all the time. That's why it's important that they should be successful. Okay? So, what I've done over the last 10 or 15 years, aided by some of my colleagues who are in this room, are trying to identify areas of projects, technical areas, which we should understand are important to watch as we go through. I started off with 7 of these, and someone called them the 7 deadly sins. And we then grew it to about 15. And we then grew it to 30 of them. And almost for this lecture, but I was already started it, I went back and I actually created a smaller list, an updated list of these. So there's lots of these other ones, and you can all add to these things if you want. But these are the ones that I think are important. I've given them snappy titles here. I'm going to explain each one of them, okay, as we go through, and get to the last one, which I think remains our greatest challenge, as you'll see as I go through this. Okay? So I hope everyone's with me. Right, the challenge of scale. Basically, small systems often don't scale to large systems. Right? I can't run a bank on this laptop. Right? I can't run a big bank. I might be able to run a very small bank. Okay? That's one thing. So we've got this problem scaling. And what happens is we've got a lot of bright people in our industry, all of whom create what we call prototypes of some sort. And they show these to someone in business who said, that's what I want, right? And they've shown the prototype actually on one of these things here. There's nothing behind it. And then everyone has to come in and scale the thing up, right? And basically, what do? There's a characteristic of our industry that I think our industry uses like no other industry, that we accept every day of the week as one of the fundamental ways in which we attack large problems. That characteristic is parallelism, right? If we don't have enough power with one chip in a server, we put 2 chips, 4 chips, 6 chips, 8 chips, 16, 32, 64, right? If we don't have enough power on the chip, although we make the chips faster, we put multiple engines on the chip, okay? If we don't have enough power in the communications, connectivity between parts of the system, we put parallel fibers or whatever you want to put as connectivity in there, right? Within programs, one thread going through it, I can only get that amount through. We put multiple threads through programs, multiple instances of programs. So constantly, our industry, when we develop these large systems, is making more and more use of parallelism. We don't talk about it very much, but this is what we actually do. Parallel, put things more and more of them horizontally. And that's fine, and that helps us with this scaling challenge. You can see the chips, etc. But there's a hidden pitfall in many systems that exist. And that pitfall is the dreaded serialization point. It may exist in the business because you can only get one thread into a piece of the business. I once saw a financial system in Frankfurt and another one in Brussels in the same year that had exactly the same problem. You could only ever get one thing, and they were both in trouble. And the reaction of everyone was, throw more hardware at it. It doesn't matter how much, throw more hardware. And I kept saying, no, it won't help. Right? So we couldn't parallelize. And sometimes within our hardware itself, within the programs, we can't parallelize. And this is a problem we hit with a lot of systems as we evolve them and scale them upwards. All right? So sometimes the very nature of the problem we're dealing with is not solvable by this scaling factor. We have to go back and really rethink these things. Okay, that's the first challenge, the challenge of scale. And the second challenge, I had to put this in because of Tony and his background. Okay, although I'll just tell you each one of these, I'm going to put up what I think the sin is. Okay, and that is we can't scale because we don't recognise the bottlenecks. And this one is middleware or fiddleware. Now, for those who not have a clear definition of what middleware is, it's that stuff that I call coding application stuff that sits in the stack between the application code, which is the business processes executing, and the operating system or control program, which is looking after the hardware and all the things that are going on in there, right? And our industry is absolutely full of first-class middleware providers. Not just IBM, you can name all the other ones, right? This is stuff that you buy, etc., etc. And it's very interesting to note that in large projects, quite often when you start to probe in, you find people who are writing what's equivalent of middleware. Right? Just for those of you that work on large projects, just think about it, how often people start to code stuff. Oh, it'll be a good idea to do this. It'd be a great idea if we did this, da-da-da-da. I'm just doing this to make this easier. Right? And what we get is a whole little industry there growing up. And it starts as a great idea, and then it becomes a true problem as the project evolves. And even if the project gets live, it then becomes a problem as you try to update things. Because all the bright people who wrote this have almost certainly moved on to somewhere else. It's great. You could always find, and so this then becomes the bottleneck to progress as you go through there. All right? And so you lose this thing. By the way, these skilled people rarely use engineering standards like documentation, etc. Right? It's just code. So, right, sin number 2, it's not application of your code. This is a foolish way to proceed. If you want to look at this, just ask people, what are you doing? Why are you writing this? You'll get very good answers, but it doesn't actually stack up in the business case. Okay, method or madness. This is something very close to my heart, having developed quite a lot of methods over the past. Right? When we actually try and design and deploy a very large IT system, it's one of the most fantastic pieces of engineering that you can imagine. I'm going to show a fantastic piece of engineering later, of a different sort. But this is really complex stuff. Millions of tasks in it. You've got to bring all these things together, etc., etc. Right? And it's strange about our industry that we don't have what I call a standard engineering method by which we execute these fabulously complex and expensive projects. Right? In other words, we have proprietary ones, like IBM might have one, Accenture might have one, Microsoft might have one, Oracle might have one, etc., etc. But we don't have an industry method for engineering, real engineering this stuff. We have things for project and all that sort of stuff. We don't have that. Right? But they all start with what I'll call requirements, design, build, and deploy. They all look like that, or requirements analysis, design, build, and architect, right? And then, when you dig down a bit further, we get terrible confusion in our sort of industry, if you like. What does architecture mean? means almost anything to different people in this room. Okay? What does macro design mean? I saw a project only a few weeks ago where macro design was micro design, and there wasn't a macro design. Okay? And increasingly, and I'll come on to this again in a moment, systems integration test, as we have to put things together. To some people it means we'll put 2 units together. To others it means we'll put every unit together, end to end of the system. Right? So we've got all sorts of problems actually sitting in there because we don't have methods that are true engineering methods to give us the discipline and those sort of communications that I was talking about. And that gives us SIN 3A. You'll see what 3B is in a moment. We attempt a large IT project with no proven method. It's one of the things when I'm reviewing them, I often, please show me your method, could you? Right. There's one worse thing to do than that sin. Okay? One of the most chaotic things I've ever seen, right, was a project working with 2 different methods like that, right? Etc. So we get that as a thing. So on to the 4th. Where are we? Now this is, I'm going to bore you to death here. This is really all about where in the project are we? Right? In other words, you can sometimes see a project go from green to red in a week. I was once asked this question by a CIO who said, why did my project go from green to red in 1 week? And I asked, the answer was, it had been red for the past year. Right? It was you didn't know where you were in it. And this is, I think, one of the great problems of our industry. Let me explain it. Once again, right? Often along, I'm going to have those stages I've just talked about. It's not to where you are. Right? We don't have what I call an IT sat-nav. Where am I? What am I doing, right? So what's the problem we've got? How do we articulate the problem? Right. Now then, what I'm going to do, this is a beautiful scene here, right? I'm going to flash these things at you in about 2-second intervals. I tried to do this over the network yesterday to someone, and it took 5 minutes, and it lost a lot of its thing. But basically, I'm going to you may have seen these pictures before, but I want to come to something at the end. So just watch. And this is a large project. You'll see that eventually. And you'll see the seasons changing as well, right? So just... Right? There you are, seasons have changed. Okay? You got what it is now, right? You can see what it is, roughly. Right. That's what it's the largest bridge in the world, right? The tallest, the greatest, the grandest, etc. And from the actual language there, it's in France. Okay? And there it is. I think the engineer of it was actually British. There it is, right? Going across this valley. Right. Now then, what do you all, when you watch that, think? Compare it with an IT project, right? If you're in engineering a bridge like that, it's all physical. You can use all your senses on it, right? You can see it, you can go and feel it, you can probably hear it. And since it's in France, it will probably have a hint of garlic on it for you to smell it, okay? Right? And compare that with the logical world we work in. I've just given examples there, right, of an IT project. It's probably costing something in that region, right? There's no way with my senses, my normal natural processes, I can go in and say, where is it? Where I could see those things going up and I could see the cantilevers going up like that, right? So the following slide is a picture of an IT project, right? There's only one of them, you'll be pleased to know. There's no mistake there. That's what it looks like. That's what it feels like, smells like, right? Touch it. So that's what we're really up against, and why a lot of our projects, we can't actually find out where we are in them. And that brings us sort of, to the last. You have to spend a lot of time, effort, energy, skills, to actually know where you are in an IT project. It's absolutely fundamental. Okay? And the sin is assuming you know where you are without really checking, without diving in, etc. Okay, so those are the pictorial things. Right. A lot of people jump up and down when I do this, basically because lots of people, almost everyone in this room has written a program, and it's always been perfect, right? Etc., etc. Okay? And our industry has a lot of people writing programs. We've got probably we've now got the second and first most populous countries writing programs, right, etc. Which is good. Right? In most large projects, we do some custom software. Right? We design the software, and it gets coded, whatever we do. Right? Software then gets tested in units. When we test the units, we find problems in them. We find them. Then when we start to put the units together, we find problems in there. And in my 40 years of looking at these things, I don't actually think we've made very much progress in this area at all. We've had various moves away from COBOL to C, C++. We had objects came along, we've had Java, which I like very much, right? But you still come to that magic point in a project where someone sort of says, right, we're going to start testing, and starts producing graphs of the number of Sev1, Sev2, Sev3, Sev4 bugs in it. Right? And so we actually come to this point, which is almost the sort of come to Jesus or whatever your religion is, in a project where you know this is a gatepost through which you've got to go. And, right, we've still got lack of real engineering discipline, I believe, in writing software at certain levels in projects. Right? People who write operating systems or middleware as professionals understand these. We still don't seem to understand them in the application space who write them. People who write packages understand them, etc. But we still have this almost charge, and let's commit sin number 6. Right? I actually reviewed a project about 3 years ago where there was no testing in it. And I said to the people, do you realize this means you're going to write bug-free code? And they said, yes. And I applauded them, and I said, we'll get the Guinness Book of Records round here now, right? You can imagine what happened. So that's number 6, okay? Then integration, what I call the final frontier. Right, if you get a big problem in life, what you do is pull it apart, take it down. A bit like those guys building the bridge, they couldn't build one span, so they put all those piles in and columns, etc. So you break it down, and that's good. That's good practice. 2 reasons. 1, you can actually see the pieces, and 2, you can probably develop the pieces in parallel, which is good, right? And then the day of judgment comes again. You have to bring the pieces back together. And this is increasingly part of our industry because we increasingly have more and more pieces. And some of those pieces, the increasing number of them, are not under our control. There are external interfaces to systems out, just whatever it is, to other vendors, to other enterprises, etc., etc. Right? And what we have to get these pieces back together is the same thing that I hope aeroplane manufacturers have when they design the wing to fit the body and the engine to fit into the engine pod, etc. Right? We have to have perfect interfaces. And our industry is becoming more and more interface-centric because of all the systems that people want to join together, whether they're in your enterprise or outside your enterprise. And this made me create my first law, right? So this is chance. And this is increasingly a problem to us, right? Because we don't... Some interfaces in our industry are actually fabulous. Like if you want your credit card interfaces, very, very strong interfaces laid down by the likes of Visa, etc. Other interfaces are, well, I'll come into you and let's send a message here, and we both got IP addresses, and there we go. Okay. So sin number 7 is actually saying, right, I've made all the pieces. Why did it take me an extra 2 years to bring them all together into a working system? Right? Success is only when you get it into a working system. Okay. Someone said that to me once. It's just always left me with a deep thing. Now, will it work in practice? It's the last but one now I'm coming to. These are the four, let's call them characteristics, or parts of the system that has to work, and they all have to work. First of all the technology has to work. All the servers, the endpoints, the connectivity, etc. has to work together, right? Then you have the people who run and manage that every day, right? IT delivery, we call it. They have to all work properly, else it won't work. Then you have the end users in your business who you have control of, you can teach, and you can actually make things happen with. They have to work, right? And then the fourth category, and this category has sprung up over the last 15 years or so, are the people outside your control. I think today, something like 1/5 or 1/6 of the world only has access to the internet. So just imagine what's going to happen when the rest. These are the people about which you get no control at all. Okay? So all those things you have to imagine have to come together. And the end users are the most important. I was at home a year or so ago, and my wife had to get me off the ceiling. I was watching the television news at the time when Terminal 5 was being launched as a great British, whatever it was, okay? And this guy came on the television, and he said, well, we've had 10 days of hell. But he said, well, we've fixed the baggage system now. The only thing we need to do, it's working perfectly, he said. It's working perfectly. The only thing we need to do is to teach the end users how to use it. Right? The end users are part of the system. So everyone has to be able to use the system. And increasingly, these end users are not under your control. And that trend will continue. Right? So sin number 8. Very, very hard message to get through to people. And you only realise this, unfortunately, at the end, if you're not aware of it at the start. Okay, so now on the last one. Change, the final frontier. Right. I have no doubt about the excitement of working in our industry. Right? It was exciting, it is exciting, it will be exciting. And the reason for that is, every day you wake up, something is changing. Right? It is not a stuffy old industry, it is one which is constantly getting changes coming at us. Right? And when you're trying to serve business, you find these changes are not just coming from the project work, they're coming from the businesses themselves. You know, the whole financial world now, or part of it, is in chaos, or pseudo-chaos, or doesn't know that tomorrow we're not going to have another type of credit crunch. Right? So anybody who's working in the finance industry, there's people, got to do this, got to do that, etc., etc. I mean, you know, the expense system in Parliament must be one of these things that people are beginning to look at, etc. Right? So we get all these changes there, right? The technologies that we use change, and not only do the actual varieties of them change. While people were trying to install internet systems for PCs, people were putting wireless devices around the place, small wireless devices, and you had to change all that, right? And so we're constantly in this hosepipe of changes that are coming at us. Right? Reaction to a lot of these changes in the projects is to resist them. Change freeze, right? And we do that, and when we're doing that, we're actually losing the real opportunities to really move businesses forward, etc., or to use new technologies. And I think this stance is somewhat self-defeating, because the more you resist change, the more it builds up, and then the more discontent you get. And why is that? Right? It's because we're afraid to accommodate change. We know what it's going to do is change the plan. Right? It's going to change things. But it actually, in resisting the change, we may not get the real success. So I've thought about change in IT for a long time. And how do we really understand it? And then I went away, and I really thought quite deeply. And I found two people who really understood change. Two people who I think we could learn and can learn a lot from if we just do a bit of translation. Here's the first guy. Right? That's what he actually said. He didn't say the survival of the fittest. Someone else said that. He said it after they'd said it. Okay? That's what he actually said. Right? So what Darwin was saying was, if you can change your rate of survival, etc., is better than something that can't change. Very fundamental. And it means the same sort of thing to an IT project. So that was the first man. And then the second man, I sort of focused on the change, was this man. It is the same man, actually, okay? On the left here is Isaac Newton before he joined IBM. On the right is Sir Isaac after he'd been through the induction course. Okay? Well, what insights this man had, right? He noted something, right? So I looked at all the stuff he'd done. And basically, he gave us these 3 laws. Now, for those of you that suffered these at school and in university, know them. These aren't how he wrote the laws. He wrote them in Latin, actually. This is just sort of common ways of doing it, right? Things don't change unless you pull, do something to them, right? And the degree to which they change is actually proportional to the amount of push and pull you give on them. And when you put in a change, something resists it equally, like that. Okay? And I think he actually understood this, and you can translate it. So what I did was translate into IT terms these things. You're probably already doing it in your own minds now, once you understand these. Okay? You can read them. Weird, isn't it? That he saw what change really meant and what the basic forces were as regards how you were going to knock something off its path. You were going to take it out of the plan, right? And if it was a big knock-off, it was going to go that way out of the plan, etc. And if you didn't understand this, it's the 3rd law, then you probably are in no state to understand what change is going to happen here. Okay? So, the great man, and Darwin, actually, I think, has got some messages in there for us. If we can really distill them a bit further, we can actually bring out some of these what I'll call natural laws that are so important to us if we are to improve ourselves. All right, so basically, if you think what I've just done, right, I've taken you from my tool bag through a bridge in France to Sir Isaac, okay, and sin number 9, which is we don't listen to these people quite like we ought to and translate their thinking of old into our thinking of new. Okay, so I'm going to conclude on the last slide. I think I'm about on time now. It really is the most exciting industry we can ever have. Right? And it's due to this change we get. Change, change, change all the time. So we can't stop change, we've got to keep going with it. Right? But sometimes the sheer excitement overrides common sense. We don't recognize these patterns or bad patterns that I was talking about, and we get risks in there. Okay? We don't have the natural laws, or we haven't actually written them down properly, that are truly our bedrock. But we do have what I call some bad patterns. Okay? Finally, we are, as an industry, the greatest instrument of change to business. And I think that's going to remain so, because I can't see anything else replacing us in the foreseeable future. But we need to get better. Okay? The final sin. Okay?
Well, that was stimulating, thought-provoking, and exceptionally well delivered, and I'm very grateful. Maurice, thank you very much indeed. Maurice has very kindly agreed to field some questions, and the floor is now open for you. Please, if you would like to ask Maurice a question or pass an observation about his talk, could you please put your hand up, and a roving mic will come to you. Please await that. And could I please ask you just to say who you are and your affiliation, who you're with. One here, John O'Sullivan.
Thank you. John O'Sullivan, Thames Communications, which is very small at the moment, but I have a background in very large-scale systems at British Aerospace and British Telecom. Thank you for that fascinating tour, and I recognise all of the sins. Can I focus on sin number 8, which you had 4 components, technology, the operators, internal users and external users, just to show you that I've remembered. I think there's another component, another sin, which is the data, the quality and accuracy and presentation and everything else of the data. Whilst you might say that's part of the users, be they internal or external, but I think it is sufficiently sinful to be at least a component of a sin in its own right.
Yes. I actually had data quality. You're absolutely correct. It appears more and more now, because what we've got are, often you're taking mature systems and converting them to new releases, all that sort of stuff, right? And I actually had it in the one section on you can't see it after the bridge, right? And it is very, very difficult sometimes to understand the quality of the data. But I think our industry has been going now for so long that we've got a lot of what I'll call smelly data sitting around there, and we're copying data all over the place, right? And taking replicas, all that sort of stuff. So the actual accuracy of data is very, very important. I agree. Yep. Totally agree.
In the middle, Bob, and then at the back.
Bob Azarati from the Office of Government Commerce. We have the challenge of trying to help government departments deliver their very big programs. And I recognise all of what you say. And my conclusion is that the only way of responding to this is to be less ambitious, because I'm not sure that we can build our capability to manage the complexity of change sufficient to meet the challenge of a lot of what we try to do. Would you have some sympathy with that?
I think I've got some sympathy, but I think we just need to get better at understanding change, right? I think if we don't do that, the world is changing around us faster and faster in terms of the events that we have. And if we limit that change and we box it in, and we say, oh, you can only do this, you can only do that, then the problems of the business of the world are going to get further and further away from us. Right? So I think we have to get better at understanding and managing change. I think we misunderstand change far too early in the cycle, and therefore we don't get it right.
But don't you think that the scale of the challenge is a compound of the complexity
Yes.
of the project we undertake and the degree of change?
Yes.
And I keep reaching the conclusion we have to take things in smaller, simpler steps.
Yeah, I think you're right at a functional level, but sometimes you just can't do that in terms of all the end users or something like that. Sometimes you have. One of the most risky things I've ever been involved in was changing a payment system in a Nordic bank, where 60% of the country, if it failed, would not be able to make a payment. And the economy would come down. Everyone said, we've got to split this down. But we just kept looking and looking and looking at it, and we couldn't split it down. We just had to do it like that. I think there are specific challenges in government. We could take it offline. Right? Well, but having been involved in some of them, I think the biggest problem I see in government is that by the time a contract's awarded, everyone is so tired, you're never going to get anywhere, right? On both the government side and whoever's won its side. It's like gladiators in the arena, and at the end they say, well, who's the last one standing? Well, no one's standing. So I think in government, the contracts are too big before you start. Personal view.
Hello, Maurice. Thank you for a brilliant talk. My name's Alex Brewer. I'm a humble IT auditor for my sins. Although my background is in like an accounting and all those kinds of finance-based things, I actually studied music. And I found that was actually a really good thing to have studied to do what I do now. Because when you showed the black slide, I immediately thought of the situation where we're never actually dealing with the object itself. We're always telling stories about it. And my work as an auditor means to hear, I listen to stories about something you can't see. So I'm just wondering, what part do you think storytelling plays in all this business and how important it is?
I think lots of good stories get told about the state of IT projects. When I worked in hardware design in IBM in the US, we had this senior vice president who was convinced IBM should then build a supercomputer. And so nobody wanted to build this because it was just a waste of time. But we had this project, right? We had this project upstate New York where we had a project plan for the supercomputer. And the vice president used to come and look at this every month. And he did it for about a year or so until he got disinterested. And we'd actually spent very little money on this. So sometimes, the only way to overcome this is to do a deep dive and to say, show me. I want to see that module. I want to see that design. Explain that micro design to me. Get the evidence out, right? Because I think a lot of this veneering goes on in IT projects. Just be hard-nosed.
Otto Benz from Accenture. Some of the sins which you've outlined seem to me that you need to be able to spot them. And there's a lesson there maybe for management. Do you have any comments that you might want to make about project governance?
I think you always want to get people external to any project to come in and review it. There are two reasons for that. The one reason sits in the last question, but the other reason sits in when you're inside a project, it is very difficult sometimes to see the wood for the trees. Right? There's always somebody saying, if we get this next fix, it'll all be over. If we can re-architect this bit, it'll all be over. If they could deliver that. So I think you always want to get some external auditors, reviewers, call them what you want, quality analysts, to come in and then come back, say once every month, and sort of, if you say, this is going to work, it's going to work, and to really shout it out, right? So I think the British Computer Society could do a great job at doing this in terms of who are the experts in our industry, whether you pay for them or not, I don't, a commercial proposition. But I think it's always bring people in who've seen this before, right? Who are experts.
Hi, Maurice. John Chapman, IBM Hursley retired. Maurice, you triggered a few thoughts in my mind about when you were talking about interfaces. I've still got physical and mental scars about architectures and interfaces, and it just occurred to me, I wonder if you'd like to prescribe, well, first of all, an example of a really good interface, if I've ever met one, and secondly, what more could we do to improve on this sort of these ideas?
Okay, you can build interfaces that are either extremely narrow, right, and therefore on either side of them you have a lot of what I'll call parameters that you put through, or you can build interfaces that are very wide, where you know specifically when you come through this part of the interface what you're going to do, right? Or you can build interfaces like, say, exists in the finance world on when you transfer money through Bax or Visa or those sort of things, right? I think the interfaces actually are quite often industry specific, right? In other words, in part of finance, there is like that. And, you know, you can argue. I got a phone call about, for those of you that are into SOA, service-oriented architectures, there's been this huge debate going on that should we have fine services or should we have coarse services with lots of things going on them. And I had a phone call from someone in Scandinavia one day who said, we've just designed this system and we find the one interface that's got 65,362 queues on it, right? Do you think this is a good interface? And I said, it could be worse, right? So I actually think you really have to look at what it is you're doing in that component there and what it is you're doing in that component there and how do you get... And still our industry doesn't have a definition of what a good interface is, other than in some specific financial systems. And those, let me tell you, are absolute, I was going to swear then, awful to change. You know, the change cycle is 2 or 3 years on some of those financial institutions that are linked together that I've seen. So we need to think about interfaces a lot more, a lot more.
Evening, Morris. Alex Noble, Cisco Systems, and before that, IBM. You seem cautiously optimistic that methods might, or improved methods, might bring greater benefits. One of the big concerns I've seen in troubled projects is too often the team have managed the method and not the project. How do you see bridging that gap between where the documentation and the method are sitting and your grey square where the code is actually spiralling downwards?
I used to mentor Alex. Good question, right? When we talk, I always spot, and I hope I'm not defending anyone from North America, right? But there's this huge problem between the word method and methodologist, right? In the United States, we've got the methodologists coming to you, right? And I think it's because people want to be methodologists and not method executors. And we've got that problem in spades sometimes that I've seen. People want to invent methods rather than actually use them. And so you need to spot the people who are really there with the method and its governance, rather than I'm engineering this method and I'm putting this new step in. Okay, you're right. It's a bit like the writing middleware. We've got so many bright people in our industry, all of whom are graduates, talented people, that everybody wants to create something, which is great. But sometimes we need people not to create, right, but to actually have military discipline on that sort of thing.
My name's Andrew Brown from University of Southampton. And I've just spent the last 2 days at the IEE at a conference on semiconductor variability, which is all about the problems of making incredibly large systems with bits of silicon where the feature sizes are shrinking daily. Spookily, the conclusion slide at that conference was pretty much similar to your conclusions. About how everything's getting smaller and it's exciting and so on and so forth. Now, the thing about building a large integrated circuit is that you have hundreds of engineers, years of development, typically $20 to $40 million spent in development costs. And then you get to this magic point, which is called tape out, which is where all the design process is over, and all you can do is send your design off to the silicon foundry to produce the silicon, which is going to be wonderful. Now, at that point, you start getting into what's known as non-recurring engineering costs. Okay, now these will typically be another $30 to $40 million for a piece of silicon. The first chip costs $40 million, thereafter they're a cent each. Now, the point is that after you've committed to tape out, if you want to change a single bit a single wire, if you want to change anything at all, that'll be another $30 million. So my thesis is that maybe all these problems could go away if you simply made people pay $30 million every time they executed a linker. The focusing effect of that might mean everything worked first time.
Yes, yes. You're absolutely right. A colleague of mine, who's not in IBM now, was a chip designer, and he and I compared large projects with the way that they design chips, and you know the errors you make and all that sort of stuff, and then you have to come back and then you go through testing again, and we concluded there were some patterns in there which were very similar to the two things from chips to very large projects. So I think yeah, but in silicon projects you've got an awful lot more tooling that takes you from the basic design through to manufacture, or at least we have in IBM, than we do. We've got lots of tools that take us various stages through a large IT project, but they're nowhere near as integrated as the tools that you've got in chip design that I've seen. Okay? Yeah, maybe. I actually think there's a generalized tool, I think, for expanding out of Newton's laws of IT that we could actually make in there. Yeah.
Jeff Sharma, Birkbeck College and ex-IBM. Maurice, I want to take you back to Charles Darwin, who explained how change can take place in living organisms through very small steps, each one of which has to work.
Yeah.
It seems to me that's the principle that we've actually overlooked in large system development. I'm very sympathetic with the view of the gentleman who spoke earlier that you can't actually do large change. You can only do small change.
Right.
And therefore what you need to do is to make small changes incrementally and test at each stage. And when I say test, what I mean is test in the real world with the real users.
Right.
This has one great advantage, which is that it tests the interfaces early in the project rather than late.
Right.
So the question is, how can we structure projects such that the various pieces are tested together with almost empty functionality, or with pieces of functionality that already exist, and then through a prolonged series of iterations actually get to the level of functionality that we want. By doing this, what we have done, of course, is to change at each stage. And if we need to go in a different direction, then maybe there's an opportunity to do that. But I point to successful pieces of software, such as operating systems and middleware and databases that have been around for decades, and you only have to look at them to see that they have evolved through many, many iterations of releases, each one of which had to work.
Right.
So I offer that to you as a prescription for a way of tackling this problem.
I think you're absolutely right. I think that's what I was trying to imply, right? But if in a large IT project, someone writes a contract there, whether it's internally in an organization or what, right? And the goal is to get you from that contract to whatever that contract says in the plan, right? And we don't have these incremental approaches which actually say, this is how I'm going to manage change throughout it, right? In other words, this is how I'm going to introduce type stuff into. One of the most fabulous projects I've ever worked with was the introduction of smart cards into the UK, right? Which did exactly that. It did bits of terminals, bits of smart cards, etc., and changed a bit here. So yes, it's that mentality where you plan for change rather than resist it.
My name is Paul Drake from Vivas, and before that BP. A couple of things. Firstly, you can have in both medicine and in engineering, you can have perfect little widgets which work in isolation, but when you mix them together and make a large system, you sometimes get unexpected outcomes. Now, it's possible that the last observations are bearing on this, but I wondered if you could comment on that and the effect of that in IT projects. And the second is that there's a military observation that no plan survives contact with the enemy. And I suspect that there's a whiff of that about IT projects as well, and I wondered if you care to comment on perhaps another sin.
Yeah, I think the first bit comes back to my first law of integration, which says, if you don't design these things to fit together, right, then they probably don't, right? It's by sheer chance that they do, and we commit. In the early days of the internet, right? We had chairmen and CEOs of companies standing up in front of the stock exchange and all the press saying, "Wow, we're going to build this wonderful website that's going to change our business." Right? And what they didn't realise was that the front end of this thing was different, but 99% of it backwards was the same. Right? And you couldn't make the back any different to this because of the legacy like that, right? And I've thought about quite a few military analogies of IT projects, and some of them maybe I shouldn't do this, but some of them I try to classify IT projects when I look at them as, this is a World War I type project, right? We're all gonna, and I've coined this term that when they get into real trouble, people get trench brain, all right, rather than trench foot. And then you get the World War II things where people are trying to do things very fast. And then you get what I'll call the Vietnam thing where everything's behind a tree, right? You can't. So, yes, I think there are some good analogies to be had with military projects, and it's just up to us to understand them. But we're still trying to do World War I projects quite often. Okay.
Okay. Well, I'm sure that we could have gone on for much longer with questions. We'll give Maurice a break. Thank you very much indeed for your participation. I'd like to invite our Deputy President, Elizabeth Sparrow, who's going to say a few words.
Well, ladies and gentlemen, I'm sure you'll agree with me that we've had a superb evening. Maurice, thank you very much for such a fascinating talk, which has given us such new insights and new things and new challenges to think about in terms of project success or failure. And thank you very much for standing in for Tony's story, which was very welcome and very much appreciated that you were able to do that for us. Maurice, you described an industry that's full of changes and full of sins. Sounds a pretty good place to work to me. One of the things you said earlier on, if I heard you correctly, is that you said, if anyone walks out of this room saying they've learnt nothing, then I'll have achieved my objective. I have to tell you, Maurice, I think you might have failed a little. Because I think we'll all have learnt something new and had something new to think about, something for us to consider, something to challenge our views of projects and how to succeed. I wonder whether you know about Maurice. He's a man of extremes. On his LinkedIn profile, Maurice says, I work on extreme challenges. And he says, if there's an IT challenge that can be classified as extreme, I tackle it. Well, I think Maurice has given us an extremely good evening. So may I invite you to join with me in showing your appreciation of Maurice's lecture today. And I can't finish today without mentioning two other things. I'd like to say a very big thank you to those on the judging panel for the Lovelace Award, and chaired by Ian Horrocks of Oxford, who I believe is with us today. So thank you very much to the efforts of the judging panel. And finally, but by no means least, thank you to our own excellent events team. They always impress me with their professionalism and cheerfulness and the fantastic way in which they organise these events. And so I'd like to say thank you to them too.
One final announcement before I close, and that is, as is traditional, to announce the 2009 winner. And the winner is Professor Yorick Wilkes of the University of Sheffield. And we will now look forward immensely, I'm sure, to another prestigious lecture next year that he will deliver.